Hi students, hello, how are you? I hope you're all doing good, studying hard, and I hope you all have seen my previous videos where I've talked about the three types of reaction: combination, decomposition, and displacement. So today I'm going to talk the fourth type of reaction, that is double displacement reaction. So let us quickly get into the topic and understand the meaning of double displacement reaction. So double displacement reaction, children. So though the name displacement has come here, it doesn't mean that displacement is exactly taking place. So please don't get in the wrong notion of writing more reactive, less reactive. I've seen students answering in the questions asked with respect to the more reactive and less reactive. So please don't get into that confusion. Double displacement. So if this word double comes in front of displacement, this is completely different reaction. Okay, so here, children, when this reaction is taking place, actually this will take place in aqueous solutions. Okay, so this will take place in aqueous solutions. So aqueous solutions, I hope you all know, when salt or any acid or base is taken in water. Okay, so here it is taken in water. So here the solvent is water. Okay, so the solvent is water. So this takes place in aqueous solution, and here, children, there will be exchange of ions. Okay, exchange of ions. So I hope you all know this term ions. Already it has been introduced to you all. Ions are charged particles. Okay, so charged particles exchange takes place. So already you all know there are two charged particles we have. One is positive charge cation, and another one is negative charge anion. Okay, so here positive and negative attraction will be there, and there will be exchange of ions. Okay, so double displacement reaction, anybody asks you to define, so double displacement reaction can be defined as the reaction. Okay, the reaction in which exchange of ions takes place. Okay, exchange of ions takes place is called as double displacement reaction. Okay, so just because displacement has come, please don't get confused. That's the main thing. So the reaction in which, okay, the definition is the reaction in which the exchange of ion takes place is called as double displacement reaction. Easy, right? So there's one a small activity in the textbook, if you all have seen. So they have taken two solutions. Okay, solution means they have taken the sodium sulfate in water. Okay, that's how the solution is made. And they have also taken barium chloride. Okay, barium chloride solution. Solution means in water. Okay, so these two are colorless salts, children. They are taken in water. So as they are taken in water, you have seen this word aqueous being used. AQ, aqueous. Okay, so sodium sulfate and barium chloride in water. Sodium sulfate and barium chloride in water. So what happens here is, children, sodium is a positive ion, sulfate is a negative ion, barium is a positive ion, chloride is a negative ion. So these are salts. So obviously in aqueous solution they will be dissociated into ions. So this positive and this negative, there will be an attraction, and this positive and this negative, there will be an attraction. Okay, this is how the exchange of ions takes place. So what will happen? Barium sulfate will be formed along with sodium chloride. Sodium chloride. Okay, so here this is also called as precipitation reaction, children. Why? Because a very white color, beautiful precipitate, white color powdered precipitate. Okay, white color powdered like thing will be floating. Okay, so when you mix two solutions, sodium sulfate and barium chloride, a white color precipitate will be formed. Okay, so please mention this white color precipitate. So this white color precipitate is nothing but barium sulfate. Barium sulfate is a white color precipitate form. So since it's a precipitate, it's a solid. Okay, and sodium chloride is aqueous. So if you can see the reaction here, sodium chloride, sodium sulfate and barium chloride reaction. So sodium is a positive ion, sulfate is a negative ion, barium is a positive ion, chloride is a negative ion. So sodium and chlorine positive negative attraction, barium and sulfate positive negative attraction. So this is how the reaction has taken place. So this is a very important reaction, children, very important. So please practice this reaction very carefully in your notebooks and just don't study the reaction. Okay, it should be written in the notebooks and practice. Then only the valency part, how Na2SO4 has come, how BaCl2 has come. Okay, so this formulas and all will get thoroughly practiced only if you people put it in your notebooks and practice. Put in the notebook and practice. Very important. Okay, so practice will make you perfect in these reactions. So now let us quickly see another activity. So you have to mix two solutions. One is lead nitrate and potassium iodide. Okay, lead nitrate. So it's a solution, children. So aqueous, I'll write here, and potassium iodide. So how will you solve this? How will you interpret what is the product? So just take this. In every case you can take this. This is a trick we can say. The first part of the salt will always be positive. Second part will be negative. First part positive. Second part negative. So this positive and this negative, there will be an attraction. This positive will be attracting this negative. Okay. So here, so what is formed? Lead iodide plus potassium nitrate. Potassium nitrate. Okay, so here, if you can see, children, it's again a precipitation reaction. Why? Because there will be a yellow color of lead nitrate formed. Okay, yellow. This is the yellow color lead iodide formed. Okay, sorry, lead iodide will be yellow color precipitate which is formed, and it will be a really bright yellow color. Okay, so when you mix two colorless solution, a bright yellow color precipitate will be formed. Okay, so precipitate is nothing but it's like a solid which is remaining undissolved in the aqueous solution. Okay, it's a solid undissolved in the aqueous solution, and potassium nitrate will remain as aqueous. So this is solid, this is aqueous. So here, what is the color of the precipitate formed? They ask, it's yellow, children. Okay, can you name the compound precipitated? It's lead iodide. Lead iodide. Write the balanced chemical equation. So just let's write. So lead, children, it's PbNO3 twice. Okay, lead nitrate. So Pb actually has a valency of positive 2, and nitrate we all know NO3 it's a negative 1. So only crisscross the numbers. So that's the reason we are getting a brackets here. Okay, because this 2 is applicable for the nitrogen also, this 2 is applicable for oxygen also. Plus potassium iodide. Potassium is K, children, iodide is I, both have valency 1 only. Okay, so if you don't know the valency part, I would like you to go to the grade 9 textbook and quickly learn the valency part. So very shortly I'll be uploading a few explanations from grade 9 textbook also. So you can refer them also. So these two are aqueous solution, children. Okay, so here this is positive, negative, positive, negative. So this positive and this negative will interact and form PbI2. So there's an exchange of ions. Since lead is 2 valency and iodine is 1 valency, this is how the interaction takes place. Plus KNO3. So it's potassium also is valency 1, nitrate also has valency 1. So there will be KNO3. So if we want to balance this equation, how will we balance? So let us first see the polyatomic ions. Polyatomic ions need to be balanced first. So if we keep a 2 here, so it's 2NO3, 2NO3. NO3 is balanced, nitrate is balanced. But potassium has become 2 here, but potassium is only 1 here. Let's keep it 2 here also. So now potassium also 2, potassium also 2. Iodine has become 2 here. Iodine is 2 here. So it's balanced equation. So the lead iodide is the precipitate which is formed. So please practice this equation, and this is called as a double displacement reaction and a precipitation reaction also. Okay, so this is both double displacement. Why double displacement? Why? Because the exchange of ions have taken place. And it's also a precipitate reaction. Why precipitate reaction, children? Why is it a precipitate reaction? Because a precipitate, a solid is formed which is undissolved in the solution. Okay, so this is all about the topic double displacement reaction. Please do like, comment, and subscribe to my channel. If there's anything you have doubt, please do comment. I will try to solve it all. Thank you.